Using graphs and tables, verify whether or not f of x equals 10 to the 1/3 x and g of x equals 3 log of x are inverses, including checking any domain and range restrictions and comparing and contrasting any intercepts. Okay, so let's first just check our graph for the reflection. We want to know if this is going to be a reflection across the line y equals x. So from the looks of it, if you were to fold on that dashed line, then these would align and match up. It does appear to be symmetrical in a reflection, so that checks out. And let's also check the intercepts and see if those follow the properties of an inverse function. So looking at the intercepts here, we have 0, 1, and on the other one we have 1, 0. So we see that those are switched. 0, 1 becomes 1, 0. So those also appear to fit the values for an inverse function. And now let's look at our table. So we're looking for, again, values where xy will become yx. So I see here 0, 1 and 1, 0 match. So do 3, 10 and 10, 3. Those both would qualify for an inverse function, but the other ones actually do not. And we need to consider one more thing just before finalizing and saying, oh, it's not an inverse function. So just looking at our actual graph, what are the domains and range restrictions on these? With our g of x, we see that it actually approaches the line x equals 0, but never touches it. So we do a restriction on our x there, that x has to be greater than 0. And then with f of x, our x is not restricted, but our y, we see that it cannot touch when y equals 0. So we know that f of x, or y, has to be greater than 0 here. So let's make sure on our table that that is valid. So f of x, those are all bigger than 0, so we're good there. And then on the other side, x greater than 0, well, -3, that's not valid for that function, and 0 is not valid because it would have to be greater than 0. So those points actually aren't important, and the other two that we have do show that it's an inverse function. So we can say that it's going to be an inverse function of f of x. So our final answer will be yes, the functions are inverses. The tables show two pairs of values that are inverses. So we can say that these are inverse functions. Our answer is yes, the functions are inverses. The tables show two pairs of values that are inverses. The range restriction of y is greater than 0 for f of x is seen in the domain restriction of x greater than 0 for g of x. Yes, the functions are inverses. The tables show two pairs of values that are inverses. The range restriction of y is greater than 0 for f of x is seen in the domain restriction of x is greater than 0 for g of x. Also, the y-intercept of f of x, 0, 1, has the reverse coordinates of the x-intercept g of x, 1, 0. Moreover, the graphs of the functions appear to be reflections of one another over the line y equals x.